Lady Ada, what is this?
Hi, everybody, and welcome to the last show and tell of 2020. Thank goodness this year is almost over. It's me, Lady Ada. With me is Mr. Lady Ada. But we've got a whole bunch of people all lined up from around the world. They're going to come by and show you some cool technology, maker stuff, 3D printing, cosplay, code, calendars, and more. We're going to get straight into it because we got a lot of people. Let's go check in with Kevin from the freezing Midwest.
The freezing Midwest, yes.
Come on, Kevin.
Hey, how's everybody doing? It is so great to see that 2020 is almost over. I'm glad you said that, Lamore, because we're all ready.
Yes.
So I know there's a lot of people in line, and we want to get through it. First thing I want to say, I said it last week because I wasn't sure if I was going to make it today, but thank you, everybody from Show and Tell. It's been an amazing year. As crappy as 2020 has been for a lot of things, it's been really good in the community. So thank you from DigiKey, from myself. It's been great. So one thing I want to share is we did a contest with Hackaday back in, I believe it was September, October timeframe, and it was a circuit sculpture contest. And these designs were so incredible that we thought we got to do something with them. We can't just have a contest and have it all go to waste. So we have put together a 2021 calendar with the winners of the circuit sculpture contest. And you can see on the screen here, this is just a couple of them I'm going to show you. It's just so cool. And we've actually added, I'm going to run down to September really quick because it's my favorite day of the year. We added a lot of important dates in technology history. And as you can see, September 9th, 2021 is CircuitPython Day.
Yay!
So we're not done with adding all that into this calendar quite yet, but it's going to print, I believe, next week. And I know it's already 2020, so we're actually running this into 2022 to make up for, or 2022 to make up for the missed month.
All right, team, we definitely have to do CircuitPython Day on September 9th now.
What's that?
It's the snakiest
I said we definitely have to do CircuitPython Day on September 9th of 2021 now.
That's a good day.
Yeah.
Yeah. That's what I found it. So if it's wrong, we'll change it. It hasn't been printed yet.
No, it's not. It's not wrong, and we're definitely going to do it now.
Yeah.
All right, sounds good.
Okay.
Hey, everybody, CircuitPython Day, September 9th, 2021.
You heard it here first.
Yeah, you hear it here first. So, stay tuned, and we can definitely get some of these out. We'll give them out on social media. We'll give them out, different ways throughout the year. Hopefully, we can get some events towards the middle of 2021 and see some of you people that we've missed everybody in person, and let's have a great year. And again, thank you everybody for such a fantastic 2020.
All right, couple things. First, thank you, Kevin, and everyone at DigiKey. I sent their senior team a note today. I CC Kevin. We had a really good end of year. Our team thanks DigiKey, our community thanks DigiKey. Everything really came together this year, from AdaBox to our partnership to helping out makers. And kind of fun side note, I started Hackaday like 17 years ago, and it's still the same logo. It's still called Hackaday. I have nothing to do with it now other than I read it. I made a Hackaday manifesto of all the things I wanted to do with Hackaday. I eventually did them at eink, eventually did them with more here at Adafruit. And then I've watched Hackaday and even told some of their team, like, hey, here's some of the things that I wanted to get to, and you're doing it. And one of them was a calendar that's just like this, which is like, let's take all the cool things from the community, do a calendar, because Hackaday was basically like publish a hack every single day.
And it would be like a hack a month.
And there's a community, and we are what we celebrate. And if you want to see cool electronics and things, you have to celebrate it. So this is a really neat, two of my favorite things in one, Hackaday and DigiKey, all in a calendar, all part of this community. So thanks for doing this with Hackaday, Kevin, and very cool.
Yeah, absolutely. And the team at Hackaday, they're so great to work with. They're such a fun group. Sophie and the team, they're a lot of fun, and love working with them. It's a great partnership.
Shout out to Sophie.
Shout out Sophie.
All right. Well, thank you so much, Kevin. Happy New Year. And we get to say see you next year.
All right. Take care, guys. I'm looking forward to seeing the rest of Show and Tell tonight.
Stay warm.
All right. We're going to go to Dan next, because Dan has a pretty exciting anniversary that he's going to share. Dan.
What were you doing 50 years ago?
What's going on?
So 50 years ago this year is when I wrote my first program. I'm 63. And so this was when I was 13. I was in 8th grade. We had to do an algebra project, a math project. And my parents are both physicists. We live in Oak Ridge, Tennessee. Let me go back. This is my And I was able to use a computer that my father used at a cyclotron to collect data and process the results. So this is the first program I ever wrote. It's in Fortran 4. It's by Danny Halbert. You can see that.
I'm calling you Danny from now on, dude.
Yeah, you
It's
can
over.
fine with me. And April 13th. And this was just, I was trying to compute square roots by doing successive approximations. So I computed the square root with a library routine, and then I computed it in a loop here by trying successive approximations and had a termination condition. And I don't see the output here, but the numbers are the same. So that's the very first program I wrote. My father helped me a little bit with the termination condition, because the first time I ran this, it did 2 or 3 or 4 or 5, and then it just hung looping, and it never quite got to the last thing. So he suggested a change in the termination condition. But
So floating point comparisons bite you from the first code to the last code.
Exactly. Yeah.
Killer.
So this computer, here's a picture of the computer. It actually had some more bays than this. This is a 32 kilo words of 24-bit words, and it ran at like 50 megahertz or something, 75 megahertz. I would say this is kind of equivalent to a SAMD51 because it had a hardware floating point. But it was a nice machine to use. Used punch cards. So I wrote punch cards on an IBM 029 punch card machine. This is not the one I used. It's just a picture of one that I found. And I learned Fortran by reading this book, which is from my birth year. It's from 1957, which my mother used when she was first writing some Fortran programs. But it wasn't that old at the time. And after writing a few more of these, I wrote a few more programs, like a prime number program. And then I wrote a program to generate random poetry, which was grammatically correct. And this was like word processing in Fortran, which was kind of harder to do. So I brought one of these poems to my 9th grade English class, and they had a lot of trouble analyzing it. But
that's awesome.
This is cool. This is
I didn't tell them. Then I said, "Oh, it was written by computer." Right?
Here comes Danny with his computer poetry again.
Yeah, I'm sure they're like, what on earth is this?
Right. Well, I had a list of like adjectives, nouns, and verbs, and it would choose randomly and paste them together in a fixed sentence structure.
What's the like latest machine learning thing where it like makes a poem for you?
No, it's like I trained machine learning on 15
GPTL3 or something like that, or I forgot the name of it. Dan was doing that 50 years ago.
Right. And the reason that I learned to program is that I actually wanted to do a math project with this Digital Logic Microlab, which I would buy from Popular Electronics, that had gates and stuff, but it wasn't available in time. So I learned to program instead, and eventually I got one of these. And on the first, when I was visiting Adafruit several years ago, I brought this with me to show you. But so I've always been interested in both hardware and software.
Dude, there's a desoldering tool. It's new.
I did a series of posts and articles on Make Magazine about Popular Electronics and how that was that was the way a lot of people got into programming. They would read something in there and they're like, I'm gonna the programs were included in there as well, and you would like retype them, and then you would
right. And this was before this is before personal computers. So the first personal computer is like 72 maybe or something. This is a couple of years before.
Yeah, this is like gates. You got gates and you've got unijunctions. Enjoy. Go have fun, kids. That's
right. Yeah.
Well, outstanding, Dan. Thank you so much for sharing this. And today, you just pushed the beta for CircuitPython 6.1?
6.1.0. So Jeff did that today. Yeah.
Jeff did that.
Yeah.
Gotcha. So 50 years later, you're still writing code, publishing stuff. The computer is a little smaller. You can fit in your pocket now. But what an amazing 50 years. I'm looking forward to, the next few decades. Yeah, next few decades together of publishing and writing code.
All right. Thank you very much.
What is it going to be next?
Thank you, Danny.
Thank you, Danny.
I hope you did well in your 8th grade
And
class.
And your beat poetry. Okay.
Thanks. Awesome.
All right. Next up, let's go to Brent.
Hey, Brent.
Hello, that was really cool. I didn't get to experience that because I'm younger than Dan, and like my first programming experience was not the same. But I noticed like on the Popular Mechanics they had a new touch on-off control circuit, and Circuit Python there's Touch IO.
Yes,
Yeah.
that's right. Nothing and speakers.
Full circle.
Yeah, total full circle. So this past week I did a short project. If my camera wants to focus today. Almost.
I see a tweet.
Yeah, it's really bad at focusing. I have to fix that.
It's okay.
So we had an existing project in the learning system for displaying tweets. Dave Estelle did it, and it was for PyPortal. And since the MagTag came out, we have Deep Sleep, and we also have native Wi-Fi. And so this project fetches tweets every 15 minutes and displays it on the screen, and it's really nice and crisp.
Yeah.
The e-ink screen is really nice. Even the Twitter logo is really good. And it displays your handle, the full name, and then the text of the tweet, and then it goes to sleep to save power, and every 15 minutes it will wake up. And it's not a very complicated guide, but it's really good if you want to start parsing information and showing it on your MagTag from an OAuth API. And like Twitter's very, very important this year. You can set this to any Twitter account. I have it set to mine, but you can also set it to tracking COVID stats. You can set it to looking at the news. I usually keep like another screen open with the news, but I've just had this on my desk since it's not as invasive.
Yeah,
I
that's
have
cool.
a big monitor glaring at me.
I've built a bunch of these MagTag projects just because I like the non-glare. Like if I'm like I have my to-do list, I'll just stare at it, and then it doesn't flash and annoy me. So yeah, totally agree.
It's great.
Oh,
It's
cool.
like passive display.
All right, the guide is live, so people can try it out for themselves.
Yeah, I'll post it in Discord. Have a good 2020.
Have a great New Year,
Looking
Brent.
forward to your next 40 plus years of writing code, Brent.
I know.
I can't wait until I can come on
save
when
your
I'm.
code.
I'll be like, here's my first program. Everybody will be like,
Right.
oh my god.
I
remember.
don't have my first program anymore. I gotta
Exactly.
go find it. I know what it is,
Yeah.
but I don't know where it is.
I don't even know if I have it because we like write everything to disk and just keep erasing now.
Yeah,
That's
this is
no
the problem.
physical
Like Dan has a printout, but we saved ours to like floppy, and like the floppies died. So it's like Dan. This is why Dan's generation.
We can all visit the GitHub Arctic Vault when the ice caps melt and get our code. Okay.
I can't wait. Bye, guys.
Thanks, Brent.
Oops. All right. Next up, let's go to Noe Pedro.
I just wanted to comment on that. I can't wait till like Gavin's grandkids are like, you had to use your hands, just like a Back to the Future.
Yeah.
So
This week was like how Phil likes to say, a receipt for 2020. So all the projects that we did for this year, I think was like 42, I think, with guides and all that. And like I couldn't even fit all the projects into the video, so that's what was this week. But for next week, we want to preview the Dark Saber build.
Yeah, so I needed to build a stand for it because like I've been working on it and it kind of takes a lot of space on my desk. So I built a little stand for it and props it up there. Pedro, if you want to turn it on, we can take a look at the thing working.
Of course, this was inspired by that Hasbro one that's coming out soon.
Yeah, the stand. I saw that Hasbro is making a FX version that will be released like sometime in 2021. So I was like, hey, they should make a.
Damn, that looks good.
It's pretty fun. I like it. And I put together some other things too, some cat animation so I could show kind of like the assembly because I'm really into that. So give me a sec here to pull that up. And we'll do the hilt first. All right, so the hilt, I needed kind of a visual way to show how the pieces are fitted together. And one of like the most important pieces, I think, is like hidden inside, right? So I got these two screws, and the thing on the inside is what I'm calling the coupler because it kind of couples these pieces together.
Mhm.
But it has a hole in the center, so it allows like the cabling to pass through, and it's fairly thick, so it makes these pieces really rigid when you put them all together. You just kind of slide into each other, and then these two screws kind of fit in like that. And then there's like little cavities in the inside that allow hex nuts to press fit into, so you get this really nice mechanical fitting. So hopefully that shows how that bit is put together. And then I have one last one. Let's see if I can switch to that one really quick. This one is the blade. So the blade is two pieces. And whoop, that's not one. That's not the right one. There it is. So the blade is in two pieces, and I have these two pockets to the inside, so I could fit these two screws and these hex nuts inside there. And one of the things I found when I built it is like I needed to add these drafted angles so I could actually maneuver the screwdriver. It's kind of hard to fit it in there. So I really like that. Super secure. You don't need to use glue. and the LED strip fits in that kind of center channel there. But I put those together just to kind of visually show how this assembly is, at least for those pieces.
Yeah, get hex caps so that you can like fit a narrow. They have like super narrow Allen wrenches, and that way you don't have to. Area, maybe.
Yeah, that's a good idea.
I did get like an angle, a little bit for our screwdriver. So
sweet. All right, so so this will hopefully be the project, like the first project of 2021. Yeah. So
great way to kick it off.
Slice into the future.
Yeah.
All right.
Thanks, guys.
Thank you.
And we'll be playing the recap video during Ask an Engineer, and everyone stay tuned because we're going to be doing even more in 2021.
You bet.
Totally.
Nice.
All right, folks. Bye.
All right. Next up, Scott. What's going on?
Hello. As you know, the holidays have just passed. We celebrate Christmas in our house. So I actually made a Christmas ornament for a handmade gift for my family and my wife's family. So here's the final version. A lot of them live in Michigan. My wife's from Michigan. So it's a Michigan-shaped with like the towns, and the traces on the front are actually run where the highways are as well. And then I made these snowflake designs, and you can touch them to change what is happening. I can't do it through the camera. So there's 6 snowflakes, and they do different things. This one, like the longer you hold it, it picks a color. This one is like fading red and green. That one is just a fading white. So if you have like white lights on your Christmas tree, this is like how bright do you want just a static white. And then this one is just a random like color sort of walk. So I did that. It's Osh Park After Dark, and it's running CircuitPython, of course. So you can see Happy Holidays message here. It's just a SAMD21, so reset button, flash, 3 AAAs powering it. I did put a stemma on there. It does work, but I don't really have any demos. And then this is the debug edge. So this is how you just attach something on there to do the initial program, which is super convenient.
All right.
Outstanding. And, speaking of heirlooms and code for 50 years, one of the things you'll be able to look back at that 50 years from now and look at the code you wrote, because I'm pretty sure text files and USBs, like something showing up as a drive, is here to stay. That's not going to go away. Yeah. So that's kind of neat. And you have a stemma thing. You can connect these together over the years. And one thing we were talking about is maybe next year we're going to do like a yearly CircuitPython ornament. So this might be a little preview of 2021.
Yeah, and I like to show my work. So here's the first rev. You can see this yellow wire here is like I forgot to connect the neopixels. And these red wires are actually connecting capacitors for the power for the neopixels. So things are not always correct the first time, and that's totally normal, and that's totally okay.
All right. Thank you,
thank you,
so much,
Scott.
Thank you.
All right.
Jeff, what you got going on?
Hello. So a couple of weeks ago, I came on and said I'm working on this thing to show icons from Font Awesome. And tonight, that's what I'm doing still, but it's kind of packaged up as a library. And you can call out the icons by name, and you just say, make icon of, and then whatever all these names are. And so this is happening in real time with the newer font reading technology that's in Adafruit bitmap font. It's actually reading out each bitmap just when we call for it. And plus it's waiting a half second between. So it's really fast.
It's fast. And
that improves all the fonts as long as you convert them into this newer PCF format, no matter whether you're doing Font Awesome or not. That's a really nice improvement. But yeah, I'm going to at least make a gist out of the code that loads up the icons and toss up the links in the live chat in just a minute or two over on Discord.
Wonderful.
Very cool. This will help a lot of people build their own user interfaces. We make it easy, but this will make it look better.
You add those little accents, and really it just sells the whole thing so much better.
All right.
Wonderful.
Thank you so much, Jeff.
Thank you.
All right. Good night and Happy New Year.
Happy New Year.
All right. Paint Your Dragon, Phil B. What you got going on this week?
Oh, hey, great. Lamar and I, we came up with a thing really quick for New Year's because everybody loves
Phil came up with it, but yeah.
the sand demos that everybody likes. And everybody hates 2020, so you can take out your frustration on it.
That's right.
and play around. And there's a guide for this. There's a UF2 you can download if you have a matrix.
Shake in the new year.
And bring in the new year. Yes, if you're doing like a Zoom New Year's party or something, you can download that and you can wow your friends there. The trick is shake it 6 minutes before midnight, and then you'll wake up.
This is the most advanced stress toy ever.
Yeah,
I love the sparkly effect.
and that's all it does. You shake it and you
That's all I want.
As it should.
and you get a new year. So
All right.
and other thing, I was one of those kids that tore apart all of his toys. See how they work. I have already dismantled my Lumen Couture mask and stuck it on a logic analyzer because I want to drive the Matrix myself. So that's just a personal goof off thing I've been doing on weekends.
Yeah,
Cool.
we will have those in stock soon. People signed up for them, so we'll be shipping them out as soon as they get in. And this is from the maker directly. There's other ones out there. Please don't buy those. Please buy the ones from the maker themselves and now us because we're a reseller. And I think one of the reasons that they were like, hey, this would be cool if Adafruit sold them is because we're absolutely going to hack them. That's what we do. All of us got in trouble taking apart things as kids. And that's why we work at Adafruit now.
Yeah, it's pretty impressive. I mean, the pixel density on this thing is just it's really neat. So I had to get in there. I took apart calculators and toys, and I got in a lot of trouble.
I got in so much trouble.
Yep.
I got in a lot of trouble.
Yeah, well, who's laughing now? So anyways.
Okay, so there's a guide for this. There's UF2s there you can download and play with it.
Well, thanks so much, Phil B. I can't wait till the stylings and coding and neopixels of Phil B go in and out of style the next 50 years. It'll be cool, retro, advanced, cool, retro. Like it'll just go over and over and over again. So I'm looking forward to your version of what Dan showed tonight, 40 years from now or so. So we'll see how that goes.
Oh, yeah. The neopixels, that's so tired.
Ancient neopixels.
And it'll come back and it'll be ready.
Yeah.
It'll be like slap bracelets.
Yeah.
All right. Thanks, Phil B.
All right. Next up, Liz. How you doing, Liz?
And Liz's code.
Hey, how are you?
What are you doing?
This code is 50 minutes old.
This code is actually by Sean Hodgins. I've modified it a little bit. He did this POV ornament this past weekend, and the part that really stuck out to me from his video is he has this Python script to convert images into matrix data for neopixels. And so it actually looks pretty similar to what Melissa's got going on for Blinka with the frame buffer library. So I ran a test image through and it did spit out the right stuff. So that was good. And so my idea is to take like a neopixel matrix, that like 8x8 one, and try to get images on it and hopefully maybe party pair it by next week. And so just as like a test, I have Circuit playground with the colors in that array just to make sure it was coming up properly.
All right.
It should in theory work. So
start on that. All right. Well, thank you so much, Liz, and we're looking forward to all the projects you're going to do in 2021.
Thank you, and Happy New Year.
Happy New Year.
Happy tunes and some blinky parrots.
Yes.
All right, thanks, Liz.
No problem.
Happy New Year.
We're going to go to
Saleem.
Saleem, what you got going on?
Hey, can you guys hear me okay?
Yeah.
Awesome. First time on Show and Tell, so I want to make sure everything's working. So my wife's Christmas present this year is an implementation of the very cool Pixie Cyberwig tutorial on your website and the Project M open source music visualizer. So what I did is I got one of your 4-meter strips of dotstar LEDs and the Feather M0, and by running the music visualizer on the screen, I can basically take these really cool kaleidoscopic sort of almost psychedelic images that kind of pulsate to music and transmit them to the LEDs. So my wife's a Zumba instructor, and she's been teaching everything really virtually since the pandemic started from our living room. She wanted something to kind of spice it up and kind of give a little more energy to the room. So basically, I wanted to create something that would light up and pulse to the music. So can I share my screen real quick and kind of show you a video of it?
Yeah.
Let's see. So we got screen sharing. And I'm going to share audio. I hope the audio will come through because that'll be cooler. It says, "Yep, share." And I'm going to bring up. Can you guys see the video here?
Yeah.
Okay. So here she is teaching her Zumba class with the LEDs flashing in the background. In a second, I'm going to just kind of pan around and you'll see the computer screen, what's kind of going on the computer screen that's being transmitted over to it. Here we go. So this is kind of one of the images. There's actually a whole bunch of different presets in there that do different, and it's just kind of cycling through different visualizations and creating these cool effects on the screen or on the LEDs. So that's it. That's me.
Thank
That's my
you,
project.
Saleem. What a great gift.
Outstanding. And
Yeah, she loved it. She loved it. It came out better than I possibly could have imagined.
I like how makers find a way. I mean, this is not only the best gift, it's thoughtful, it's timely, and it's something that, you'll remember. Like this is like, remember that year when I made you that thing? When we had to go through that stuff? All right. Thanks so much, Saleem.
Thanks.
Zumba Zoom. All right,
All
thanks,
right.
Saleem. All right, next up. I don't want to say your name wrong. Thijs?
Oh, Thijs, yeah.
Thijs,
Hey, Thijs,
sorry.
what you got going on?
Hi, I was formerly coding pro. I don't remember from the interview.
Oh, that's right. That's
I
right.
didn't want to say that because everyone, changes their handles, but that's what I was going to guess.
Yeah, so I didn't really know Python that well, I guess. Or I still don't know Python that well, but I wanted to challenge myself with a project that used CircuitPython to make something with this PyPortal. And so I made this display, which is like
cool.
like CPU usage, RAM
neat.
usage, GPU usage, and my hard drive or solid state drive usage and stuff. And I made this with the display.io library, I think.
Yeah.
And, I didn't really use the PyPortal library. I don't know. I just decided to do display.io.
Yeah, that's cool.
When you touch it, this is like the detailed view, and
that's cool.
Has a temperature there. I'm still working on the CPU temperature and stuff. But
And this is on the computer that you're currently showing it on?
yeah. So
All right, that makes sense. CPU is doing a little bit of work because there's video stuff going on. You have a pretty fast computer, it looks like.
yeah, let me stress my CPU here. You can see, hopefully this doesn't.
You can open up like a PDF or something?
Yeah, wow, 100%. That's a lot.
And you can
All right,
see.
well, good work. This is great. Please post this up because I think a lot of people would want to build this project. And
we just did this cyber deck thing with the Raspberry Pi 400 where you have this little display.
Yeah.
Back in the day, everyone liked to see that stuff, especially when they're using their computer, how much RAM, how much, just to get to know their computer better. Cool project.
Very cool. All right. Well, thank you so much. It's good to see you, Coding Pro, again. Or
Good to see ya.
Thijs. I just killed your name again. I'm so sorry.
It's Thijs.
Thijs.
Right.
Happy New Year. I'm going to write that down.
Happy New Year to you too. Thank you.
All right. Next up, Brent. Hey,
Hey,
Brent.
Brent.
Hi, how are you guys?
Good.
I did something similar. I moved the weather project from the MagTag onto a Titano. And I'm also using, I think I killed it, but your TMP 117s and unexpected maker's feathers. So I have one of those on each level of the house. So I can display that as well.
Oh, cool.
So using Adafruit IO, that turned out pretty cool. Pretty happy with it.
When you get a chance, tweet or email us or whatever. We have a Brent on our IO team. We'd love to feature that in the newsletter.
Yeah.
All right.
All right, cool.
Thank you so much, Brent.
Thank you, Brent.
People
Happy New
named
Year.
Brent love Adafruit IO.
It's true.
It's true.
That's what I've learned. Okay.
All
And
right,
next
last but
up,
not least, it's Larry.
hey, Larry. How's it going? Oh, you have to unmute, Larry?
Yes, forgot about that.
Yeah, what you got?
Show and tell here. So I've been experimenting with some Bluetooth low energy devices lately and some simple things from thermal printer. So this is one of those $25 thermal printers that use Bluetooth. I just bought it thinking I could figure it out, and it was pretty simple. It just does the standard Bluetooth, standard UART kind of communication over Bluetooth. And so I put a little bit of code here running with my Bluetooth thermal printer library. Let's power it up and see if it connects and works.
All right, live demo. Oh, there you go.
Oh, yeah, it's printing.
Nice.
So that was
too.
a pretty simple one. And then I got hold of one of these Bluetooth thermometers that you guys like.
Yeah.
Yeah, we just showed those off on Desk of Lady Ada. We're thinking about hacking them up and doing some stuff.
Yeah, so I found Aaron Christoffel, ATC 1441. He figured out how to hack the firmware to make them transmit the data unencrypted. So now it's just putting out advertisements with with unencrypted data for the temperature and humidity. So I'm going to do some data collection from that. But the more interesting project I wanted to show you tonight is my remote display library. And I wanted to show it to you guys to get some feedback for you as well. So this is a nice Adafruit NRF 52840 feather driving a feather wing TFT. And it's running my remote library, but telling it to send it to the SPI display. And I've got a little button on the back. If I can press it. There it is. So it's running this simple program to just do some primitives on the LCD. Now I've got that same code running on my remote display library. And if I power up this other NRF 52 feather and a remote display server. So now we're running the same program remotely over Bluetooth, and it's got a virtual button from the touch screen.
That's cool.
Nice.
So these are primitives being transmitted over Bluetooth, like draw a line.
Yeah.
And I also have a Mac and an iPad app that serves. So anything can serve as a display server, and any Bluetooth device can send the commands to the display server. But the thing that I wanted to accomplish was the same program can talk to a real display or a virtual display. And so the idea is that if you've got a project idea and you don't own whatever type of LCD, you can prototype it with an iPhone, you can prototype it on your PC, get all the graphics to look correct, and then send it to a real display or change display types, and it's all going to be kind of magically supported.
The magic is in the details. Yeah, I think that there's definitely like your display stuff out there. I check out, all of the standalone next-gen displays and see what they're doing and basically publish the protocol. That's the most important thing, because all these displays that people have done, these are like displays with UART or SPI or I2C command sets. There's no documentation. So like people always have to end up reverse engineering them. So that's like, I think the most important thing is just having documentation about what data to send and what you're going to expect on the other side.
Yep. Yeah, I'm going to make it public soon. Right now it's private until I get it a little clearer, and then I'll release it to everyone. I really want feedback. Yeah.
All right.
Yeah, you can say, I'll publish that next year.
You'll publish it next year. All right. Well, so
and then you can say I worked on that last year.
All right. Come on by when it's public and share it with people on Discord. I'm sure they'll love it too.
Will do.
All right.
All right. We have to get it going because we were a couple minutes late. We have a show coming up.
Yeah, we got to ask an engineer going. Larry, thanks for stopping by and showing off the projects.
Thank you, Saleem. Thank you, Paint Your Dragon. Thank you, Jeff. Thank you, Danny. Thank you, Liz. Thank you, Scott. Thank you, Brent. Thank you, everybody who came by Show and Tell, not only today, but all year long.
That's right.
This has been fun.
We did it. We've been doing it. We've been doing this for a decade, and we're going to be here next week because that's what we do, and that's what you can look forward to. So keep building, keep sharing. We'll see everybody next week. Don't forget, you can hang out in Discord 24/7, show your projects there. We'll be on Ask an Engineer in a matter of seconds.
Thank you, everybody.
See you all next year.
Ooh.